So welcome back. So in the last session, we have seen how to work with dictionaries, and we have explored what are the various properties of dictionaries, and we have explored various functions of dictionaries. We have done lots of hands-on with dictionaries. In today's session, let's explore about set. So let's understand what exactly is set, and let's explore various functions of set. Okay. So set is basically, if I talk about set, set is a group or collection of dissimilar elements. Similar to tuple and list, set is also group or collection of dissimilar elements. Means we can have elements of a different data types in a set. Cool. Next, then you might worry what is the difference between set and list and tuple. We'll discuss that. Right. Next, set is denoted by the flower brackets or whatever you call your curly brackets or whatever you call. So you may have a doubt now. Already we have dictionary which is denoting in this way, right? Your dictionary also is denoted in this particular way only. But how do Python differentiate this with dictionary? It's very simple. So we know that in a dictionary it's a key value pair, right? So we would be having key and value. But here in set, we would having a list of elements, something like this, where this is your first element, second element, third element. So in that way, Python can differentiate. If you are providing a flower brackets with list of elements, group of elements, not list, but group of elements, it's a set. If you are providing a flower brackets, if you're providing this curly brackets with key value pair, it's a dictionary. So that's how a Python can differentiate your dictionary and a set. But the way we denote set and dictionary is similar, but the only thing is the data in the dictionary and set is different. That is how Python can differentiate. Let's see practically, then come back and discuss more properties of set. Okay, cool. So coming to this, first let us see how to create a set. For example, if I say yes of this empty set first, of course, by default, whenever you give a curly brackets, your Python will assume it as a dictionary only. So whenever it's a type of yes, it's a dictionary only. But if I add some element like this, 1 comma 2 maybe, just I'm adding just 1 comma 2, you can see it is assuming a set because the data is different. By default, if you make an empty flower brackets, it's a set. But if you actually start adding the elements, and if you don't use key value pair, and if you give a group of elements, it's a set. And moreover, if you want to create an empty set, for example, then you can also do like this. If I say set of, it will be an empty set, right? It will be an empty set. And you can see this is your empty set. Okay, cool. In that way also you can create an empty set. Perfect. So this is how a set works. This is how a set looks. Okay, so I'll just add some elements right now. So as I told you, it's a group of dissimilar elements. So I'll just say 1, 2, 3, 4, some 4.5, a string. I'll give a string. I'll give a boolean and all those things, and this is how a set looks. Okay, this is how a set looks. Cool. Now let's try to explore more about this. Let's understand some more properties of set. So as we understood, yes, set is denoted by this, and we have a lot of elements in this. Yes, and one more important thing is set doesn't support indexing. So indexing is not supported in set. Let's take an example. Let's see practically also. So for example, now in list and tuples, we were having indexing, right? And we were able to slice element based on the positions. Means for example, if I say L of 0, I would get the first element, or L of 0 to 1, 0 to 2, I would get the first and second element, something like that. But instead, that it doesn't support. So if I say yes of 0, it would raise an error saying that set object is not subscriptable. Means you cannot slice your set. Or for example, negative indexing also, if I try, it is not possible. So set will not support indexing. Perfect. Next, set is mutable. So set is mutable, that is very good, but doesn't allow mutable elements. First, let us talk about the first point. Yes, if I want to update my set elements, I can update it. So set is mutable. So if I want to update, for example, if I want to add element or remove element, I can do that. But as it doesn't support indexing, we have to using functions only. I'll show that. But yes, set doesn't support indexing. Sorry, that set is mutable, but it doesn't allow immutable elements. Sorry, mutable elements. Let's talk about that point. First, let's see how set is mutable. So for example, if I say yes dot add, so we have a function called as add. So again, we are discussing about functions. We have lots of functions in set like this. Again, if I say dot tab and if I click on this, I'll be getting a lot of functions. Now let's start about add function. If I say set dot add of maybe 5, okay, and you can see that yes, it is able to add an element here. So from this I can say that yes, set is mutable, but we also have another point that set doesn't allow mutable elements. Means what? If you want to add or if you want to try to create an element or add an element which is mutable, it is not possible. See, right now whatever elements which we have created, these all are immutable elements. But for example, if I try to add a list here in this set, this is not possible. You can say it says unhashable type list. So we cannot add mutable elements in set. Okay. Set accepts only immutable elements. That's very important point. Okay. Set accepts only immutable elements. Mutable elements are not accepted. So in that way, we cannot create a nested set here. Means for example, set inside set is not possible because set is also mutable, right? So you can see it says unhashable type set. In the same way, dictionary is also not possible. But tuple is possible. Tuple is possible because tuple is immutable. So in set, we can have only immutable elements. Immutable elements. That is next important point. Okay. So set is mutable but doesn't allow mutable elements. Perfect. Means we can have only immutable elements. And last important point is set doesn't allow duplicate values. Set doesn't allow duplicate values. Yes. See, if you talk about list or tuple, we are allowing duplicate values, right? But set will not allow duplicate values. That is the reason if you observed already, we were not getting true here, right? I guess if you observed already, we were not getting true because already one is present, right? We discussed the same thing, right? One is equal to true in our previous sessions, that one was actually treated as true in general. So one is true right now. So one and true are equal in general. So true is not not in the present in this particular set because it is already there. So it doesn't allow duplicate values. Okay. Now let me show you a small example of how it is not allowing duplicate values. Okay. For example, if I'm trying to create a set something like this, S is equal to some random set with some random elements, and if I try to add some duplicate values, you can see, however I'm adding a duplicate values, I'll not be getting an error if you add duplicate values also. But the thing is, it will remove the duplicate values, means it will not consider the duplicate values. If you just look at here, yes, it will be 1 2 3 5 and 6. So all the duplicate values will be not considered. So in this way your set works. It will not consider your duplicate values. It doesn't allow duplicate values. Perfect. And moreover, one important point I want to raise here is, so we have understood few important properties of set, but let me take a set like this with some random elements, some more random elements, something like this. Maybe 4, 1, 2, 5, 6, 1, 2, 3, 5. So you can see these are completely something like this. But if you just have a look at your set here right now, it is sorted, right? So whenever you have all your integers, or for example, let us assume I'm having a float here itself. Okay. For example, when I'm having integers and float, it will automatically sort. So the result, I mean the set will be actually in a sorted order. Okay. It will be arranged in a sorted order whenever you're looking at your set. Okay. It will be in a sorted order. But what happens if you have string in this? If you have a string in this, it will sort alphabetically. Okay. Whenever you have a string in this, it will sort alphabetically. You can see here. So H is last. For example, if I am having A, B, C, something like this, you can see it is something like this, right? So how I'm saying it is alphabetically sorted means first comes your numbers, then comes your strings. Okay. So here I'm having 1 and 10 because like alphabetical order. So 1, then 2. If you don't have any strings, okay, let me try to create a one more string, then only we'll be getting an idea. First I'll create before this, okay. So hello and Python like this. So you can see first comes all your numbers, then your strings, okay. You can see your first ABC, then H, then A, then H, then P. So alphabetically it is sorting. And even in numbers also it is sorting alphabetically. You can see 1, after that you'll be getting 10, not 2, because of the first number, 1 and 1 are matching, something like that. So it is something like that. That's how set works. It is alphabetically sorted if it is having string, and if it is normally sorted if it is having a strings and integers. Sorry, integers and float. Okay. Now let's explore few functions of set, okay, and see how set works in different ways. Okay. The first function is add function. We already explored about this particular function, right? So what add does? It will add the element into the set. It will add a specific element into the set. As set is mutable, we can add elements like this. The next function is we have remove function. So we know how to add. So add function, what it does, it will add an element. In the same way, if you want to remove an element, and moreover set doesn't support indexing or doesn't have indexing. So as set doesn't support indexing, we can remove an element only based on the value but not based on the position. In list, we were able to remove an element based on the position using pop function, but in set we don't have that facility because set doesn't support indexing. So we have remove function here. So what remove does, as usual in set we were working with remove function, right? It was removing based on the value. In the same way, you can use remove function. For example, this is your set, and if you want to remove a specific element, for example, I want to remove 4.5, so I can simply say s dot remove of 4.5. And one more important thing is you cannot add multiple elements at a single go, or you cannot add or you cannot remove multiple elements at a single go. You can only remove only one element or one. You can add one element or you can remove one element at a single go in set. Okay, if you want to remove multiple elements, again you have to use something like loops and your logic. You have to use loops. We'll see that loops later on. Yeah. So in that way, you can see you're able to remove an element, add an element, right? Next. Perfect. One more element I'm removing 4, ABC. Now, one more important thing is we have two functions of remove. One is remove and second one is discard. What is the difference between this? Let me explain you. For example, let us assume this is your set. I'm creating another set once again to have some bit of elements. Okay. Now, for example, if I say yes dot remove of a specific element which is present in this set, it will happily remove. For example, if I say yes dot remove of 5, here 5 is not present. Okay, 5 is not present in this particular set. But if I'm trying to remove that particular element of that particular which is not present in this particular set, it will return a error saying that key error 5 because 5 is not present in this particular set. Whereas if I use discard, even discard also works same like remove only. For example, if I say s dot discard of 4, you can see 4 got removed from this particular set. But if I say yes dot discard of 5, because 5 is not present in this set, but if I say yes dot discard of 5, it will actually doesn't throw any error. That is the main difference between remove and error. If you want to throw an error when the element is not present, you can use remove. If you don't want to throw any error and make it just none, we can use discard. So either of this both, you can use discard or remove based on your requirement, right? Next, let's see one more other functions. Yeah. So for example, yeah, this is one thing. And one more important thing is, what is the main one more use of set is why I really use set in some cases. In some cases, I use set for one case, one important thing, that is to remove duplicate values. For example, you have a list of elements like this, which has having duplicate values. If I want to remove, one simple operation I can do is, I can convert into set first, something like this. First, I have to convert into a set like this. If I say set of L, automatically your list will be converted into set, something like this, you can see. Again, I can convert back into list. I can convert back into list like this. Okay. For this operation also I'll be using set. But one more important thing is this is somewhat slightly costlier operation. Costlier operation. Why? Because this, when you have a huge list, it is slightly time consuming. Of course, we have more better ways to remove duplicate values. This is one of the way to remove duplicate values from your list. Okay. So set of L. First, if I say set of L, it will convert into set. Again, I'm converting back into list. So you can see my list is back. without duplicates. That is one more advantage of set. And I can say L is equal to, if I say L is equal to, you can see your list is back with your removed duplicates. Okay, and this should be used only when your order is doesn't matters, when your order of your elements doesn't matter. If your order of your elements are mattered, then this kind of operation should not be used. But I'm just explaining you one of the example. Right, next, now let's talk about few other functions of set and very interesting functions of set. See guys, in our schooling or in some point of time of our life, we have learned about set theories, sets, right? And in sets we were having lots of operations like union, intersection, symmetric difference, and all those things. So all kinds of operations can be performed in this set. Let me show you. For example, let me create a set like this. I'm creating two sets, S1 and S2. For example, whenever I say S1 dot and give a tab, you can see some functions which are related to set, like for example, difference, intersection, symmetric difference. You can see superset, subset, disjoint. These all are the union. These all are the set functions which we have learned long back ago. I mean, in our set class, of course. But yes, let's explore these functions. For example, if I'm having two sets, for example, if I say intersection, let's start with intersection first, then we'll talk about intersection update. Okay. So what is intersection is, for example, if I say S1 intersection S2, for example, if I say S1 intersection S2, these are two sets. I'm saying S1 is intersection S2. So what is intersection? Common elements, right? So whenever I say S1 intersection S2, it will return the common elements. Okay, it will return the common elements. So here we have common elements as 4 and 5. So it is returning 4 and 5 here because these both are common elements right now. Okay, that is what intersection is. But what is intersection update? So right now, whenever I call it S1 dot intersection S2, whenever I call S1 dot intersection S2, it will return it. That's it. But it will not update any sets. Means your S1 will be as it is, and your S2 also will be as it is. You can see, right? S1 is as it is, and S2 is also as it is. There is no updation of any values. But whenever I call S1 dot intersection update S2, whenever I call S1 dot intersection update, what happens is, whatever intersection value we are having, that will be getting updated with your S1. Means what? For example, if I say S1 dot intersection update S2, you can see this particular function is not returning anything. Now if you just look at your S1, yes, your S1 got updated with the value, with the result, and your S2 will be as it is. Your S2 will be as it is. So what update does? It will update your set. If you don't use update, it will not update your set. If you don't use any update, and if you run this, again I'm running S1 and S2, it will not update. But if you use update, it will update your set. That is the main difference between intersection update and intersection. The same goes with other functions also, like symmetric difference, update, and distance. We'll discuss about that. Okay, cool. This is how intersection works. And we also have something called as difference. What is difference? Okay, let's see. For example, again, we have S1, S2. These are two sets as usual, the same sets I'm taking. And I'm just saying S1 dot difference S2. So whenever I say S1 dot difference S2, just observe carefully. You can see here, it is returning the uncommon elements of S1. Means if you just look at here, you'll be getting only S1 elements here. You're getting only S1 elements because I said S1 dot difference S2. And here we are getting the uncommon elements of S1 because here you can see 4 and 5 are the common elements of S1 and S2, right? So apart from these common elements, we are getting all the uncommon elements like 1, 2, 3 and 6 LO. 1, 2, 3 and 6 LO. You are getting all the uncommon elements. Now, if you do S2 dot difference of S1, I have done here what? S1 dot difference S2. So what happens? All the uncommon elements of S1 we got it. But when you do S2 dot difference S1, you are getting the uncommon elements of S2. Means you will be getting 7, 8, 9, 10. Let's do that. S2 dot difference S1, you can see you are getting 7, 8, 9, 10. Not because I told what? I have said S2 dot difference S1. When I say S2 dot difference S1, I am getting the uncommon elements of S2. This is how difference work. Okay, it will return the uncommon elements of your left set. Okay, sorry, of your right set. This is your, sorry, of your left side itself. Yes, so it will return the uncommon elements of your left hand set. This is your left hand set and right hand set because of your declaring it. Okay, so whatever left hand side set you are having, that particular set it will return. Okay, uncommon elements of that. Perfect. Next. Next, we have something called as symmetry difference. What is symmetry difference means? Again, for example, this is your set 1 and set 2 as usual. Whenever I call symmetry difference, it will return all the uncommon elements. All the uncommon elements, both for set 1 and set 2. So, see here, it was returning only the uncommon elements of S1 only, right? I mean, the left hand side set, S1 or S2. If I say S1 or difference, I'll be getting the uncommon elements of S1 or S2. But here it will return all the uncommon elements. You can see 4 and actually 4 and 5 are common elements, but we were not getting that in the symmetry difference. So, if you want to have all the uncommon elements, you can use symmetry difference. Okay, you can see there is no 4 and 5 in this, but you're getting all the elements apart from the uncommon elements of both the sets. Okay, so a symmetry difference will return all the elements of all the uncommon elements of both the sets. Okay, next we have union. I guess everyone know how union function works, right? It will join the two sets into one, right? So if I say s1 dot s2, you can see it is joining those two sets 1 to 10 on everything along with the common elements also, obviously. Perfect. Then we have update. So what update does is, if you call union function, if you call s1 union s2, s1 will be as it is, s2 will be as it is, but it will return the union of these two sets. But when I call update, it will update your S1. If I call S1 dot update S2, it will update your S1 with the union of two sets. Means, for example, if I call S1 dot S2, nothing it will return. But if we just look at your S1, it is, you can see in S1 we have what? The union of two sets. So whenever you see update function, guys, whenever you see update, it means that it is modifying the set, that's it. If you are not seeing update, it is not doing anything. But whenever you are seeing update, it is modifying your set. So here, whenever I am seeing this update, it is modifying your sets. So one more use of update function is, if you want to join two sets, you can use this update. So if I say s1 dot update s2, s1 will be having all the elements of s1 and s2. And s2 will be as it is, because I told what s1 dot update s2, but not s2 dot update s1, right? So you can see all the elements got updated. For example, if I do s2 dot update s1, even s2 also will be getting updated. You can see even s2 got updated like this. Okay. So next I'm taking simple one more two sets, same sets as usual. Next, so this regarding your union, intersection, symmetry, difference and difference. Now let's talk about some other functions. If you remember, when we are discussing about strings, I told you that whenever you are seeing is before your functions, like is, for sure that particular function will return a boolean value, because you're asking your Python like is disjoint, or you're asking your Python is disjoint or is subset or is superset. So you're asking your Python, so it will be returning a boolean for sure. So let's see how this works. For example, now I'm having s1 and s2, something like this. And if I call a function called as s1 dot is disjoint s2. So what is disjoint does is, I'll run this code. Yeah. So it returned false, right? It has returned false. Now let's see with some other set. Okay. I just have a look at this, then I'll explain you. Now look at these two sets. When I'm saying s1 dot is disjoint s2, it is returning false. But now whenever I'm calling this s1 and s2, and if I call s1 dot is disjoint s2, it is returning true. Now what you can do is, you can just pause this video and just think, what is disjoint doing actually? Okay, let me explain. What it is doing actually is, if your two sets are having common elements, is disjoint is false. Means what? As the name says, is disjoint. Is disjoint means, are there disjoint or not? Are they disjoint? What is meant by disjoint set? A disjoint set is nothing but the sets which are not having any common elements. Okay, if two or more sets it's not having any common elements, those are called as disjoint set. So that's asking, we're just asking your Python that are these two disjoint set or not. If it is returning false, means what? These two sets are not disjoint. Means they are having some common elements. So it will be helping us to find out whether two data structures are having common elements or not. This is very important function. Next, for example, we just look at this both are not having any common elements. That is the reason we got is disjoint as true. Okay, that is how this is disjoint works. Next, let's go to the superset and subset concept. I guess every one of you know what is exactly superset and subset. For example, if I'm having a set like this, S1 and S2. Now, what is subset? For example, if I say S2 dot is subset S1, what is meant by this? If all the elements of S2 are present in S1. If all the elements of S2 are present in S1, just observe here 1, 2, 3, all the elements are present in S1, then I can say S2 is subset of S1. Means subset means what? A part of a set, right? When you have a huge set, in that if I take a part of a set, that is called as subset. Now, when I'm saying S2 is subset of S1, when all the elements of set 2, S2 are matching with S1, then only we can say it is subset, because when I'm saying part of the set, all the elements should be there. So when I say S1 dot S2 is subset S2, sorry, S2 dot is subset S1, it is returning true because all the elements of S2 are present in S1. By chance, for example, if there is 7 is not present in this. So S1, S2 is not subset of S1. It will return false as usual. So in this way, this is called a subset. In the same way, superset. What is superset? When all the elements of S1, or when automatically when S2 is subset of S1, automatically S1 will be superset of S2. Obviously, right? Like it's like a population sample. Here we have a lot of complete data. In that we're taking a plot of data. So that particular complete data is nothing but superset. Okay. So for example, if I say S1 dot superset S2, sorry, if I say S1 dot superset S2, you can see it is true. But if I say now S2 cannot be superset of S1 as usual, common, right? For example, if I say S2 superset of S1, it is false. So what is superset? Automatically when S2 is subset of S1, automatically S1 will be superset of S2. That is common. So this is how we'll be working with sets. These are the few set functions. This will be using a lot when you want to add elements without common elements, or when you want only the common elements, or if you want to whether common elements are not present or not. All these kinds of operations we can use these kinds of functions. So this is how set works. Just practice this. It will be very easy. Thank you guys.